So this is the fan car lab. If you are absent or you're not sure how to complete the data on the back, that's what I'm going to be walking you through today. So this lab shows you two different things. It tells you about the two different types of speed. So the first type of speed is your average speed. This is going to be the total distance traveled divided by the total time traveled. So an example of this would be if I was driving to Tuscaloosa, it takes 123 miles, and it takes me 2 hours to get there. So my average speed for the trip was 61.5 miles per hour. Now, that did not mean that I traveled the entire time at 61.5 miles per hour, but that over the entire span of the distance traveled in 2 hours, this was my average speed. The second type is called instantaneous speed. This is the speed at any given point. It shows up on your speedometer in your car. An example of this is going to be, if I'm on the highway, my instantaneous speed is 70 miles per hour. But I'm stopped at a red light, my instantaneous speed would be 0 miles per hour. So you're going to learn about both of these in this lab. So you created your fan car and you got your data. And this is going to be the data that you are going to use if you were not here and you were not able to do the fan car with us. So we taped different meters on the floor, up to 6 meters. At each meter, we did an interval of tape, and you put your fan car at 0 meters, and then you recorded the distance or the time it took for it to hit the different distances. And you did it 3 times. And these are going to be your data trials. So let's say on the first trial, it took 2 seconds to get to the first meter and 4 seconds to get to the second meter, 5 seconds to third, 7 to second, and it keeps going. So that's the first trial, second trial, and third trial. So the next thing you're going to do is you're going to need to find the average speed for the trial. So when we find the average of something, remember you add all, you hit equal, then you click divide, and we're dividing by 3 because there's 3 trials. So divide by 3, and that gives you the average. So you're going to say 2 plus 2 plus 3, so that's 4, plus 3 is 7, divided by 3, or equals 7, divided by 3, and that gives you your average speed for that trial. So I'm going to do just a few of those with you. So 7 divided by 3, and we get 2.3. On the next one, we say 4 plus 5 plus 6 equals 15 divided by 3, and we get 5. So that's our average time, not speed, in seconds for all of these. Then we're going to find our average speed. And remember, speed is in meters per second. So we're going to find our speed by using this formula, S equals D over T, distance divided by time. So for our speed for this one, we have our distance, which is 1, divided by our time, which is 2.1. So I'm going to say 1 divided by 2.3 equals, and I get 0.43 meters per second. On the next one, do the same thing. I've got 2 divided by 5. 2 divided by 5. And I get 0.4 meters per second. And I'm just going to keep doing that. So you have to find your average time for all of them before you can find your speed. Once you've filled in your data table, make sure that you give it a title. Then you're going to come down here and you're going to graph it. So please keep in mind that this is quantitative versus quantitative. So you need to figure out what kind of line you're going to have. Are you going to have a bar graph or a line graph? Remember, quantitative data versus quantitative data, numbers versus numbers. You're also going to label your axes and give it a title. But you're going to have to determine which variable is going to go on which axis. So remember to use dry mix. You've got dependent responding on the y-axis, independent or manipulated independent on the x-axis. So is your speed your dependent or your independent? And is distance your speed? Or I'm sorry, is distance your independent or your dependent? You need to figure out which one is your independent and which one is your dependent and put it on the correct scale or the correct axis. Then you're going to go down here and you're going to answer these questions. Number 1, choose 2 distances at trial 3. So this is trial 3. You're going to just choose 2 distances and solve for their instantaneous speed. So remember, instantaneous speed is the speed at that specific instance. So if you did, 2 meters at trial 3, then you would use this as your time and this is your distance to find the instantaneous speed. And you're going to do that for 2 different distances. Then number 3, what type of speed are you graphing? So you're doing average speed and distance. So what type of speed are you graphing here? And that's your answer for number 2. 3, what are the forces of the fan car when the car is moving from the fan turned off and when moving with the fan turned on? What evidence do you have to support this answer? So you've read about different types of forces. You did a Venn diagram on them. So what are the forces that you used in this activity? Number 4, is the force of the fan constant or changing as the car moves along? So you're going to put your answer right here. Is it constant or changing? And then number 5, what is the effects of the force on the fan on the speed of the car? So what happened if you pushed the car further? What happened to the speed of the car versus if you just put it down and the fan was the only thing that moved it? So you're going to answer these questions and turn them in.